Hey folks, today I figured I'd do something a little bit different. Since yesterday and today we're going to be working on this review worksheet, I figured I'd just kind of go over the problems, and then if you guys had questions about them, hopefully this will give you a chance to answer them. What you'll notice that I've done already is that I've kind of taken different elements from the periodic table and then just kind of, yeah, copied them where they're supposed to go. So one of the things I wanted to say at the start is for week 13, day 3, and week 14, day 4, those two assignments, you won't be able to do these without looking at the periodic table, or you'd have to have the periodic table memorized. So a lot of the information we want for our answers is located on the periodic table. So part of what we're really challenging you guys to do here today is figure out how to use it. Let's take the first one, for example. Now, this question tells us that we're dealing with iodine. Remember, when we have the name of an element, we also have the number of protons and also electrons, because protons are unique to each element, right? So every time you add a proton, you have a new name for that atom. So for example, 53 is iodine. Iodine has 53 protons. The other thing to remember here is that the number of protons you have in a neutral atom, you have the same number of electrons. So we're also going to have 53 electrons here. Now, for neutrons, I'm going to put that in red. And just remember here that this guy, this 126, is our atomic mass. So atomic mass, remember, is a combination of protons and neutrons. What this is going to mean then is it means if we have, 53 protons, well, we can just subtract that from 126, and that'll give us the number of neutrons. So doing some quick math here, 126 minus 53, I'm pretty sure that's, what, 73? So 73 is going to be my number of neutrons. So this is going to be the same general process we're going to use for the next four other problems, is we're going to kind of use the element card over here, and then we're going to use the fact that protons and electrons are always the same, and then we're going to take whatever our proton number is and subtract it from our total atomic mass, which is the number after the dash, and that'll give us our number of neutrons. So for the second problem, let's go ahead and do this. Cobalt 27, so that's 27 protons and 27 electrons. Then, of course, 27 minus 60, that's going to give us our number of neutrons, which in this case, is that 33? Yeah, 33 is our number of neutrons. Okay, next one, nitrogen has 7, so 7's our number of protons and our number of electrons, and then 7 minus 15 is going to give us 8. Yeah, 8. Okay. Oh, something I wanted to mention here. I don't know if I've had a chance to mention this or not. Notice how the atomic mass of nitrogen is 15, but the number down here is like a decimal, like 14.01. The same thing is true for cobalt. It's 60 versus 59.93. And over here it's 126 versus 126.90. These two numbers are not equal to each other, which makes sense because they're not the same number, but they also don't mean the same thing. This number here, for example, this 15, that's just one specific atom. So, you could have nitrogens of all different types of, we call them isotopes. So they could have all different numbers of protons, all different numbers of neutrons. Wait, they all have to have the same number of protons, right? Because nitrogen, if you add a proton to it, if you change the number of protons, you change the actual element. Same number of protons, but they can have different number of neutrons. Those are what we call isotopes. But this 14.01 number over here, that is the average number, atomic mass number. So maybe you can kind of think of it like you'll have some 15s, some 14s, and then that kind of averages out to be 14.01. So it's mostly 14s, and then there's like a couple nitrogen 15s. So seeing nitrogen with 7 protons and 8 neutrons is something we don't usually see. Usually it's just 7 and 7. But that doesn't mean that nitrogen 15 can't exist, because in this case it does. Okay. Hopefully that makes sense. Barium. Let's go ahead and look at protons and electrons, both 56 here. And then for neutrons, we're going to take 56 and we're going to minus it, or we're going to subtract it from 137. When we do that, we're going to get 81. 81. That's what I'm going with. 81 is my number of neutrons. And then to finish up here, we've got 19 protons and 19 electrons from potassium. So 19 minus 39, that's going to give us 20. Cool. So there's a lot of information. Oops, sorry. There's a lot of information stored here in this little guy right here, where it says, iodine 126. It's going to tell us the number of protons and electrons, just, based on, kind of, iodine itself. And then it's also with this 126, that also tells us neutrons. So just by having the name and having the atomic mass, we can determine pretty much everything we want to determine about this atom. Okay, moving on here. This problem, now we're dealing with ions. So one of the things you'll notice about ions is that the number of protons is not equal to the number of electrons. That's true about ions. That's not true about just regular run-of-the-mill atoms. The other thing we want to know is we also want to know, the symbol. So pretty much, we don't really need to look at the neutrons at all in this guy, just because what I wanted for the answer, for example, for question number 1, will be something like F, which is the symbol, its charge, which is -1, and then I'd want to know that since it's a negative charge, that is an anion, because anions are always negative. So here we're really doing nothing with the number of neutrons. That's just kind of extra information. Once again, you'll notice here that I've taken the time to kind of copy and paste from the periodic table. How I did that is I just matched up the protons, right? I just matched it up. In this previous example with iodine and iodine, or cobalt and cobalt, as you might be able to tell, I just matched up the names. So name is kind of the same as a proton in a lot of ways. Yeah, moving on here. Okay, calcium. Calcium has 20 protons and 18 electrons, so it's going to be Ca, and then it's going to be 2 plus. In this case, it's 2 plus because I have 20 positives and 18 minuses, so my total charge is 2. And then remember to always put a plus or a minus next to it. Is this an anion or a cation? Well, cations, as we know, are positive, so it is a cation. Moving on here with strontium. Strontium 38 versus 36. So 38 is the positive number, so it's going to be Sr2 plus. Yeah, and then again, it's going to be a cation. For the last one here, our number of protons and electrons, you'll notice, is the same. So this isn't an ion. So we'll just call this radon, and we'll say it is neutral. Because in the directions here it said it could be a cation, an anion, or just a neutral atom. So the charge would be 0, so I'm just not going to write anything there for that. Okay, let's continue moving on. Okay, for this one, we're going to have to kind of resort back to using the periodic table. So based on the Bohr diagram, we're going to write the names of the elements shown. So here, in this case, what I'm going to look to do is for each one of them, I'm going to count how many electrons they have. This one's got 4. So then when I'm going to look at the periodic table, all the way back up here, I'm going to look for 4 electrons right over here. So for A is beryllium. I'm just going to put Be. You don't have to write the full names. For the next one, it looks like I've got 1, 2, 3, 4, 5, 6. So I'm looking for something with an atomic mass of 6. Scroll up again. Atomic mass of 6 is carbon, for example. C. This next one looks like it's got 2 in the first layer and 8, so it's got a total of 10. This next one over here looks like it's got 10 plus 1 more, so it's got 11. Over here, it looks like it's got 10 because the first 2 layers are filled, and then an extra 7, so 17. And then the last one looks like it's got the first 3 layers filled. That's a total of 18 plus these 2, so we're looking for an atom of 20. So for each one of these, what you're going to do is you're going to kind of look at these guys and then find them back up on the periodic table. So pause the video, take a moment to do that. Cool. 10 is neon. 11 is that sodium? Yeah, it's sodium. Sodium is Na. 17 is chlorine, and 20 is calcium? Yeah, it's calcium. So yeah, just thought I'd circle those just for you. Calcium, Ca. Okay, to help you out with this question number 9, I took this slide from notes 4.1. So remember we have 3 particles. We've got our protons, which are positive. We've got our neutrons, which are neutral. And of course, we've got our electrons. So something that you can probably see based on this is that protons are positive, neutrons are neutral, and electrons are negative. Protons and neutrons are both located in the center, which we call the nucleus, and electrons are located on the outside in this thing called the electron cloud. Remember, E- is an abbreviation for electron. Cool, moving on. The atomic number is the same thing as protons, P plus. In an ion, the number of protons and electrons are the same, or are they different? They are always different. Just because you always have a charge for an ion. So if your positives and negatives are the same, you won't have a charge. In a neutral atom, the number of protons and electrons are the same. Yep, so these 2 questions, 11 and 12, kind of go together. They're both talking about, protons are positive, electrons are negative. So if you have the same number, they won't have a charge. If they have a different number, they will have a charge. Isotopes, we talked about this a little bit. Isotopes are 2 atoms. Like, for example, you could have carbon 12 and carbon 13. So in both carbon 12 and carbon 13, they have the same number of protons because they're both carbon, right? Carbon always has 6 protons, for example, in the same way that like hydrogen always has 1 proton. But you'll notice here that their atomic masses are different. So there's 2 answers for this. You could have said different numbers of mass, or you could have said what I would have taken as the correct answer is different numbers of neutrons, and 0. Can oxygen and nitrogen have the same number of protons? No, they cannot. The reason why they can't is because protons determines identity. So your proton is the same thing as your name. Not the same thing, but your proton determines the name. So if you have 2 different names, 2 different numbers of protons. Can oxygen and nitrogen have the same number of neutrons? Absolutely. They can both have like 7, for example, or 6, or 5. Neutrons don't really matter. You can make them whatever you want. Can oxygen and nitrogen have the same number of electrons? Yes, absolutely. They're both going to form. Oh, so just so you're aware, I guess I'm kind of doing this without the periodic table because I know it so well. Here's nitrogen and oxygen. So if nitrogen has a charge of 3 minus and oxygen has a charge of 2 minus, they'll both, in this case, have 10 electrons. Just because they both want to get to the stable neon over there. So yeah, that's one example where they'll both have the same number of electrons. Cool, cool. The blank of an element is the total number of protons and neutrons. There's two answers for this. One answer for this would be atomic mass. The other answer would be mass number. Those are both examples of protons plus neutrons. What is the formula to find the number of neutrons in an atom? You're going to take the mass and you're going to subtract the number of protons. So these questions, 10 through 18, they're really just supposed to be some conceptual review for you guys so that you feel more comfortable answering questions or figuring out like what's the process to find the answers for questions about atoms. Give the symbol and the number of protons in one atom of a bunch of different atoms. Okay, so here's what we want you to be able to do. We want you to be able to see lithium and know that its symbol is Li, right? We want you to see iron and know that its symbol is Fe, or oxygen and know that it's O, or arsenic and know that it's, I'm going to double check, is it AR or AS? AS, okay, that's what I thought. Sometimes I second guess myself. Arsenic is AS, bromine is Br, copper is Cu, mercury is Hg, helium is He. So that's really easy for me because I know the periodic table. You might have to spend a little bit more time looking back and forth. The other thing you're going to have to spend some time looking back and forth is determine the number of protons. Lithium always has 3. Iron has 26, I want to say. Just double check that. Yep, 26, right here. Moving on, oxygen has 8. Bromine, I'm drawing a blank on some of these. Helium, I know, has 2. Let's look. Arsenic, bromine, that sort of thing. Okay, bromine is 35. Remember that. Arsenic is 33. And copper is 29. 29, 33, 35. 29, 33, 35. Okay, so then the last one is helium. Let's find that. Oh, sorry, mercury, Hg. Sorry, not helium. Helium's over here. It's got 2. Hg has an atomic mass, or a number of protons of 80, atomic number. Give the symbol and number of electrons for a neutral atom of each of these. So I could have said electrons, I could have said protons. Remember, in this case, since we're talking about a neutral atom, not an ion, this means the same thing. Argon is Ar, it has 18 electrons and 18 protons. Boron is B, it's got 5 electrons. Chlorine is 17 electrons. And then iodine is I, and I don't remember. It's in the halogen group, I know that. Oh, okay, 53. There we go. Iodine's got 53 electrons. So this is all just kind of, you're using your periodic table to do this. I'm going to say use PT. I also put need PT over here. Identify each atom's family. For this, we're going to want to use this guy, our colored in periodic table, to help us out. Sodium's over here, iron's over here, hydrogen's here, chlorine's here, and argon is here, right next to chlorine. Okay. Sodium. Sodium's in this dark blue one. We call those the alkali metals. Alkali metals. Oops, I put that in the wrong spot. Alkali metals. Iron is over here, so it's with the transition metals. Hydrogen's over here in its own little family. We call that hydrogen. Chlorine's over here with the halogens. And argon is over here. That is the noble gases. Oops, I spelled noble wrong. Put Nobel instead. LOL. Okay, so a lot of this is just using your periodic table. Hopefully, getting a chance to see me do it takes a little bit of the mystery out of it. Thanks for watching, guys. Have a great rest of your day, and we'll see you next time.